So today we're going to talk about real numbers. Okay, this is actually lesson 02. Yes, we are skipping 01. We're going to kind of pick and choose a few of the sections as we go. And so this is the first one, and this should be review from you, or for you. Okay, so if you look at this, it says a number line can be used to show the sets of natural numbers, whole numbers, integers, and rational numbers. So real quick, let's review the natural numbers. Do we remember what those are? What were those? 1, 2, 3. So basically the natural numbers are the counting numbers. Those are the numbers you learned when you were a little baby. Did I say, how old are you? Oh, 1. Okay, and then you have 2 and 3. Then we learned what the whole numbers were. What's the difference between the whole and the natural? There's one difference. 0. Yeah. The whole number has 0. So basically the whole number is 0 plus all the naturals. Then you learned about the integers. In a nutshell, what were the integers?
Every whole number.
Yeah, the positive and negatives. Okay, and the integers are generally what we seem to graph on the number line. And then the rationals. What were the rationals? The dreaded word that you all hate starts with an F and then goes with an R. I just do that. Fractions, okay? Everybody seems to hate fractions. All right, so what we're going to do is we're going to look real quick at this. So if you look at the natural numbers here on this first number line, we graph 1, 2, and 3. Remember, we put a dot. Biggest thing I can tell you, what I'm going to be picky with on number lines, make sure you have the arrows, because a number line does extend indefinitely in both directions. Then you have the whole numbers. Notice you added 0, and then the rationals. Okay, so let's go ahead and look at the next one. A square root, remember, is one of 2 equal factors of a number. For example, 1 square root of 64 is written as 8. Okay, the non-negative square root is called the principal square root. And a number like 64 with a square root that is a rational number is called a perfect square. So let's talk about perfect squares. 1 squared is 1. What's 2 squared?
4.
Remember, 2 squared means 2 times 2. Okay? 3 squared is 9. Okay? 3 times 3. 4 squared is 16. 5 squared is 25. 6 squared is 36. Now what we call all of these is we call all of these the perfect squares. Okay? So 1, 4, 9, 16, 25, 36, those are all perfect squares. What would be the next perfect square after 36? 49. Then 64, then 81, then 100. Usually good to know the numbers 1 through 100, the perfect squares. So it's kind of some of those you should file away to memory. Okay, let's look at this next statement. A number such as square root 3 is the square root of a number. It is not a perfect square. If we were to use our calculator and we took the square root of 3, we would see that that's 1.73205 ... Remember, anything that's like the root 3 that keeps going forever and ever is called an irrational number. Now, what is the most famous irrational number? Pi, yeah. Pi is the most famous irrational number. In fact, to this date, they've got computers that are running nonstop trying to figure out what the next digit in pi was. And oh my gosh, back in 1996, they were so excited because they found another digit of pi. And then they've been trying to, I think they found one just recently, like a year or 2 ago. And so they've got these computers that are nonstop running calculations trying to find the next digit of pi. These people need lives. Okay, so anyway, I mean, when you think about it, they've actually got a poster that extends all the way around the room that has all the digits of pi. No, I don't have that. Okay, but anyway. And so if you would actually go search the number pi and go to some websites, they will have numerous digits. I mean, just goes on and on. Okay, so here's kind of a Venn diagram of what we know about the numbers. We know we have the naturals, then we have the whole, then we have the integers, then we have the rationals, and then the irrationals are kind of the odd people out here. So that was like pi. That was like root 3. Okay. Root 5 is another one. So those are the irrationals. And all of these numbers we call the real numbers. That was always something that was hard for me to understand. I was like, well, what's a real number? A real number is just any number. That's all it is. So when you hear about the real numbers, it's just any number. So let's go ahead and look at an example. So we're going to start with the number 5/22. And so if I go back to that Venn diagram, I need to figure out, where does 5/22 belong? Is it a natural number? So is that a number you can count on your fingers? No. Is it a whole number? No. Is it an integer? No. What is 5/22? It's just a rational. It's just a fraction. Okay? Square root of 81. What do I know the square root of 81 is? 9. So now we're going to deal with 9 because that's a little bit easier to deal with. Is 9 a natural number? Yeah, you can count it on your hands, right? So we got natural. So if it's a natural, it's also a whole. And if it's a whole, it's also an integer. And if it's an integer, it's also a close rational. So what you're going to probably want to do is maybe bookmark that page P7 when you're doing this on your homework. Okay? That because it's got that diagram. And so if it's a natural, it's going to be everything. If it's a whole, it's going to be an integer and a rational. If it's an integer, it's going to be an integer and a rational. Okay? And so it's going to be one of those things that might help you to kind of look at that. So let's think about square root of 56. Is that a perfect square? Do I know what the square root of 56 is? No. Okay. So now I need to think about that. So it's not a natural. Is it a whole? No. Is it an integer? No. Can I write that as a fraction? No. So what's it going to be? An irrational number. So that's kind of the checklist you need to go through. All right. Let's look at another one. Graph each set of numbers on a number line. Then order the numbers from least to greatest. So the best way to do this is to kind of write these things as decimals. Okay? 5/3. And you could use your calculator for this if you wanted. If I were to divide 5 by 3, does anybody know what kind of decimal I'm going to get? 1 point something. Okay, you could use your calculator to get like 1.6 repeating. What about -4/3? That's going to be negative 1 point what? 3. Now for those of you wondering how are they getting that? 4/3 is what is a mixed number? 1 and what? How many thirds? 1/3. So then you have your 1.3. 2/3 I know is 0.6 repeating. And then -1/3 would be -0.3. So then all you're going to do now is you're going to draw your little number line. Okay, I'm going to start with 0. And then I'm going to go ahead and put 1, -1, -2, and then 2. And so now all I'm going to do is plop these in. So 1.6. So from 0, I'm going to go about 1.6. Now you're probably like, well, 0.6, how do you do that? Eyeball it. Okay, 0.6 is a little over halfway there. So this would be the 5/3. The next one is -1.3. So where am I going to go? Left, and then a little past this one right here. Okay, so that one is -4/3. Okay, let's look at the next one, 0.6. A little past halfway, so we're going to call that one 2/3. And then the next one will be little here, which is -1/3. So now what they want us to do is order us least to greatest. So least means which is smallest. So I'm going to do smallest to biggest. So all I'm going to do here, notice I've got to use the brackets just like they did here. I'm going to write -4/3. Oops, there we go. -1/3, 2/3, and then 5/3. So all I'm going to do is just write the numbers as I see them. Now if I wanted greatest to least, I would start on the right and go to the left. Okay? So let's look at the next one. Oh, we got some interesting ones there. 6 4/5. Anybody know what that is?
6.8.
6.8? Okay, worst comes to worst. If you've got your calculator, if you've got a calculator with you, what you could do is do 4 divided by 5, and you would get 6.8. Okay, what do we know root 49 is? 7. So then you've got 6.3 repeating, and then root 57. I'm sure nobody knows that off the top of your head. So that's one where you're probably going to want to have a calculator with you. If not, let's see what we got here. Let's go to the calculator and we'll check it out. Okay. I don't like that one. So we'll get a little. Oh, there should be another one. Let's see real quick. Oh, guess not. So we'll just end up doing square root of 57. Maybe. There we go. Square root. So the square root of 57 is 7.5. We could probably round it to 7.5. So 7.5. So now let's go ahead and do our number line. Okay, always got to start with 0. 1, 2, 3, 4, 5, 6. There's 6. Thank you. And there's 7. Okay, so 6.8. Going to be about right here. We're going to write that as 6 4/5. The next one will be root 49, which will be right here. So I'm going to write that as root 49. The next one will be 6.3 repeating, so that's going to be a little beyond 6. And then 7.5, so we're going to be all the way up here, 7.5. So I need to go ahead and write these least to greatest. So what's going to be my smallest number, folks? 6.3 repeating. What's going to be my next one? 6 4/5. What's my next one?
Square root.
Root 49, and my next one is?
Square root of 57.
Oh, I wrote that wrong, didn't I? Oops, sorry. This should be root 57. Thank you, you caught that. Sorry, I wrote that wrong. So it should be root 57. Okay, so I need to make sure I put the little squiggles, and then that is your answer from least to greatest. Okay, questions? All right, I'm going to do something that, yeah. You know what we're going to do? We're going to call that good today. And the reason being is that, yeah, we've kind of had a long day with our covering books and that. So this is going to be your assignment. This will be due Tuesday. Now, you are not going to be able to do all of the problems. And in fact, if we turn to page P10, we will have just gotten about through 1 through 18. We didn't get all the way through 18. We didn't get all the way 13 through 18. But you might be able to start those and do okay. Okay, we did not get to write each repeating decimal as a fraction in simplest form. We will start that on Monday, as we will start a problem from 13 through 18 on Monday too. So if you just want to get started, you could probably do 1 through 12. Okay, if you have questions, please ask. If you wanted to do more, that's great. Okay, but 1 through 32 will be due Tuesday, and we will do the second half of the lesson Monday.